Yeah, we can see it.
Okay, great. So it's going to be the fourth lecture, and specifically we are going to talk about a case study. Okay, and specifically we are going to focus on Linux. So the objective is obviously the case study discussion, and specifically we are going to discuss about 4 or 5 top operating systems. So those are currently the market leaders. So specifically, if we see that there are these 5 different operating systems of mobile and desktop version, those are leading the market. And if you want to see their market share, then you can go online and you specifically can find. Then Android is having the lead with around 40% market share. Then comes the Windows, then iOS, OS X, and finally the Linux. There are some other versions also available. And obviously, those are some open source implementations. As you do know that there are multiple distros available of Linux, and people do their own sort of modifications in the base code, and then they design their own distributions, and then means accordingly either they go for the just a non-profit distribution, or they do create their own companies and then they sell those distributions just for profit making. So in this process, specifically, we are going to discuss some of the things about each of these operating systems, and then finally, we are specifically going to focus on Linux operating system. So starting with Android operating system. So Android, as you well know, that Android is specifically developed for mobile devices, specifically for phones, and it is offered by some of the best manufacturing companies around the world, like HTC, Motorola, and specifically now earlier used to be that Nokia was not in the race, but now Nokia is also coming up and keeping the pace. So with this sort of Android operating system, what is the major advantage? That first thing is open source. Secondly, that it's a free code that allows people to do sort of modifications so that you can develop your own apps and different kind of versions of Android operating system. So in this way, when we see that where does its power come from? So this power comes from the Linux kernel. So the underlying Linux kernel offers the multiple opportunities that are in the hand of Android users, so that they could go for their own kind of modifications, and specifically for any sort of opportunity, if they see in the market that now the focus of the users, the mobile device users is going in a particular direction, so then you can move accordingly in that particular direction, develop your own dedicated versions, and then specifically go for sale or use. So some of the releases with respect to Android, those were in market starting from the alpha version, and as you might be knowing that alpha and beta, sort of the terminologies that usually come into picture when we see that something is coming into market just for testing purpose. Okay, so when we see that alpha is a version or beta is a version of anything, then those are just kind of test cases, and that's why those are written here as internal cases. Okay, company just released it just for the testing sort of purpose. So like if we do discuss this scenario with respect to browsers, okay, so then we have Chromium. So Chromium is the kind of open source implementation of Chrome, if you want to say, but we will not say exactly like that, because we do know that there are multiple implementations. Those are added in terms of add-on and other functionalities in Chrome, which are not open source. Means it is not always the case that if the base software or the base code is open source, then you are always going to get the implementation. So those are coming to be in future. In addition to the base code, those are also open source. Okay, those might be or might not. So specifically in this case, alpha and beta were released specifically for testing purposes in 2007 around, and then the Android released brought forward with the Android 1.0 API level 1. Now here API is the application programming interface sort of. So whenever you have different kind of intermediate layers or kind of interaction layers you want to say, then you do need APIs. So APIs are specifically come into picture when you do want to make some sort of programmatical changes or something like that. So then with respect to each new release, API version 2 do get improved, because first release obviously do have the basic fundamentals with respect to any release, either it is a hardware or software or whatsoever. either firmware or something like that. Then APIs, corresponding software like the device drivers, also do get modified because the underlying hardware architecture got changed. So you need to improve the corresponding APIs also. And it is not always the case that always the underlying hardware got changed. That's why you are going for API change. It might be because of you have added some new sort of functionality in that particular device, and that's why you have to change the device driver also. For example, if some device doesn't support multi-user, then obviously that particular device driver need to be modified if the later release supports the multi-user functionality. So in this way, we can see that API level 1, API level 2, API level 3, and so on. All these things are coming into picture. So in September 23, 2008, the first API level came into market, and then level 2, level 3, and that's why so many their code names came with different releases, starting from Cupcake, Donut, Eclair, and Froyo, Marshmallow, Nougat, and currently I think there is some Snow, something is going to be released. So in this way, there are multiple Android versions, those are in market. Some of them are older that we do not use, and specifically many times we do see that specifically means a phone, a cellular phone with very good configuration is coming with very handy price. What is the reason? The reason might be that the underlying OS is very good. So when you buy or when you go for the purchase of a specific device, then you need to see the both sides, the hardware as well as the software side. Because if you do have a very good powerhouse in terms of hardware, but and means unless you don't have the right kind of OS, because who will ride that horse? That OS is going to ride that horse. So if you don't have the right kind of operating system, then your doesn't matter how powerful your underlying hardware is, that is gonna be a kind of waste, because your OS will never exploit its full potential. So in this way, you are supposed to be concerned more with respect to OS as well. Means it's a kind of trade-off. Means it's a debatable issue that we usually say that whether hardware is more important or software is more important. But if you keep a good trade-off between both factors, then I think it's the best one. Okay, so moving forward, we are going to discuss Windows. Everyone knows that obviously it is one of the best desktop OS that we usually have in market, and it is going to capture the market for the very next few years, because when we see the visibility and the ease of access, the readability, the readiness of so many options, and you can see the different sorts of charming icons and all these things, then Windows is the leader. Obviously, it is far superior than all its competitors in terms of desktop OS. Yes, we do talk about the Mac OS and all, but point is again there is a there comes a trade-off of money, means your financial condition and all those things. Because when we say the market share, then obviously Mac is never going to defeat Windows, because ultimately the people who are in a particular city or whatever is your sample size. If you are taking samples from a city area, it might be the case that Mac OS are more or something like that. But still, in city areas also, you will not find Mac OS people more, because ultimately the cost factor is too different from Windows. So ultimately, Windows is giving good functionality. Means comparatively, if we compare the price versus the performance, then I think Windows leads. So in this way, we discussed that Windows also offered multiple versions starting from the Windows 1 to Windows 10, and the evolution took a period of around 30 years from Windows 1 to Windows 10. So starting from the very basic releases of Windows 1, 2, 3, 3.1, then we got the major Windows got the major breakthrough with Windows 95. That was the first milestone version that we can say, because in this version specifically they gave the good GUI support, and they came with basic utility developments like the calculators, and the Windows 3 supported the colorful version, but still in 95 the colors range were also very good. So in this way, 95 was a kind of complete OS for desktop version. Then came the 98 with more improved versions, then Millennium 2000. And again, the second milestone, major milestone, means some of the people do claim that Millennium and the 2000 were also very good. And specifically 2000 is remembered for its server support. So that's why 2000 was also a really good OS, but that was specifically with respect to server functionality. But in terms of a normal desktop OS, if you talk, then I think after 95, then the major uh, comeback from Windows side was in terms of Windows XP. So XP was a kind of full-fledged operating system offering different types of functionality for multiple users, and its graphic support was also really good. Then came the Vista, but it was supposed to be considered too heavy for some of the systems, and many people didn't appreciate it. So it didn't get spent well. And then came the Windows 7, 8, and currently we are seeing the Windows 10, which is the market leader. So Windows 10's superiority is way ahead than all the Windows versions. So in this way, Windows is doing a really good job. Then we do have the iOS. So in terms of iOS, we do know that specifically Android was developed for mobile phones, but there was a great competitor, and that is iOS. And when we talk about iOS, again, the price factor comes into picture. So when we say that why Android is good, so it offers you the transparency and ease of access. But specifically in terms of iOS, though it is not easily accessible, but yes, its beauty, elegance, and perfectly magical performance do get people towards it, and that's why many of the people, those are supposed to be the customers, means kind of loyal customers, because many times people do ask in case studies that when we say that we are talking about mobile phone OS, then specifically we talk about iOS, then why it is getting so popular? Means despite its price and all those things which are not affordable, obviously. So how it is getting popular, and how Apple is making money having so pricey products. So then people do say, and there is so many research went on, and then they found that there is a set of dedicated loyal customers of this iOS products, OS X products. So in this way, Mac means Apple is making profit because of all these things only. So when we have a dedicated set of users, then those dedicated set of users means it is not like that those are kind of slaves, or they don't have some kind of mind or something like that, because they do have money, and they do have education, then all the things, then why they are just stuck to one of the range of products or something like that? Because when we say that it's a kind of market study that people do use many times, and in a variety of sectors people have used it, in that you need to build your own ecosystem. So when you build your own ecosystem, then you make all the things like this, that if your user is using one of your device, then he needs your another device for its sustainable development, you can say. Because for example, if many of the iOS applications, if you start to use, then firstly you have to pay price for that, and that also heavy price for some of the applications. And once you have done that, then you are obviously, if you have given price, it is not like that they have just taken price from you and they are not giving you quality. So quality is there, but price is also there. So after paying price, obviously you are going for that, and quality is also there. So you are now kind of binded to that, because you are used to that particular kind of application or device, and its quality is also best in the market. So it's a kind of thing that you are habituated to it, like Jio did. Initially, they offered a free service for 1 year and all the things. Later on, people got used to it. So in the same way, it is not like that Apple simply distributed free of cost. But yes, they initially kind of, you can say, attraction. They offered a picture. They offered a kind of imagination in the mind of people that this sort of functionality you are going to use. And you are going to be out of world experience. So in this way, people started to use it. And when they started to use it, they became kind of a part of that ecosystem. So despite knowing this fact that yes, we are paying a heavy price for this particular product, they are using it. And as you can see that the economic condition means the daily livelihood of people is getting improved. So people also do expand, means they do more expenditure, and they want to use more sophisticated products, and similarly the technology. So when one company grows, then with the time, if it is earning profit and it is not spending its profit on its R&D, then obviously it is going to lose at some time in future, like Nokia did Nokia made so much profit, but with time it didn't spend too much. Means obviously not too much, but at least it should have spent the sufficient amount of its profit into the R&D wing or something like that. That Nokia didn't, and you know the results. It came at the bottom of market. So now again, Nokia is trying to keep the pace. And with so many releases of iOS, we do have these some basic releases starting from 1, 2, 3, 4, and there are so many that you know are available in the market. So ranging from the mobile applications, Mac also provides the desktop version, and obviously that comes in the form of OS X. The OS X version uses a monolithic architecture and microkernel architecture. Means in many of the OS X versions you can find the hybrid kernel implementation. We have already discussed the use of microkernel, in which the sum of the functionalities of kernel are shifted to user space. That's why the size of kernel gets reduced. So that's why we call the microkernel. Similarly, the monolithic means the whole kernel, all the functionalities are there in the kernel space. So kind of whole OS is lying in the kernel space only. So in this way, OS is making both sides, means OS X is using the advantages of both sides. Some of the popular releases are listed down here. Means those are not the latest one, but starting from the popularity, then 10.0, 10.1, 10.3, then starting from 2001 in OS X version 10.1, and now it is continuing. So next one comes with the focus that we are specifically going to talk about, and that is Linux. Okay. Why we are specifically focusing on Linux implementation? First, I think it's open sourceness that gives immense power to users, because many times, like we discussed the power of OS in terms of Mac OS and something like in Windows. But the point is that when you don't have the open source, then you don't know the underlying architecture. You don't know what is the software code inside. So, point is, whenever people don't have the actual code, because nowadays we do think that who has this much time just to go into the source code, then to explore all these things, and then to do the relevant modifications, then finally converting into a specific distribution, and then go for market selling or personal use. If you want to use, obviously the people who are going to make for personal use, they are not going to use Linux or something like that, because specifically if they are supposed to first devote so much time into the development and then go into use, then obviously no one will go for that. That's why some of the dedicated freelancers across the world came together, and they made some of the dedicated teams specifically for the different distribution development of Linux, and they provided people free of cost. So in this way, these freelancers means it looks like that if they are so talented, why they are doing all these kind of things? Why not to join some company, make a rich amount of money, and means live a lavish life? But point is that as we see the example of Linus Torvald, the kind of you can say the innovator of Linux. So he is also a very well-known programmer. And when you have this kind of intelligence, then you do have all sort of money options in your hand. People do come, companies do come at your door. They ask you to join. But when you have some kind of that, no, I need to do something different in this field, then you are remembered as a pioneer in this particular field. And similarly happens with Linus Torvald, and he is considered as one of the biggest innovator, and one of the means usually people do consider, means in my opinion, it's going a little bit off the track, but in my opinion, people then say that he is a philanthropist. Like people do talk about the jobs and all, and Gates and all, means specifically families. I'm not saying the means when we say that Gates and all, then specifically we specifically talk about a one person name. I don't want to take the name. Means we specifically want to take one person's name, and we say that this is the sole person who landed this company here. But it is not like that. There is a dedicated team behind every work. But always there is one leader. So that leader, initially they make so much money, and later on they go for the philanthropic kind of work. So those kind of things are recognized, because whenever we see all these things, then always one factor comes into mind: what is the amount? So when we see the amount, then we recognize and we consider that it is the best philanthropic work till date or something like that. But when we see the people like Linus Torvald, then Linus Torvald kind of people means they are also doing the service to community. So when we say that there are freelancers, the actual freelancers who are not even charging a single penny from people and who are making the lives of people easy, then those are the people who are actually the biggest kind of philanthropist. So in this way, Linus Torvald, what he did is really commendable. So starting from the basics of Linux, kind of inspiration comes from Unix, which was originated in 1970 by Ken Thompson, a brilliant scientist at AT&T Bell Laboratories, and then with the succeeding developments in the coming few years, Unix became so popular that it became a kind of standard for servers and specifically for backend processing. But when Unix came into market, first thing means again people demanded that is it open? Means can we have some sort of practical hands-on in it and something like that? Then it was a specific problem because even the person who created that thing, he or she doesn't usually recommend this sort of thing that somebody comes and do create a mess in my whole work that I developed over a period of time with so much sheer intelligence and all the dedication. So that's why in case of Unix, this was a problem. Then comes the case of Minix, where it was developed by Andrew Tenenbaum in 1987. And Tenenbaum is a well-known writer of operating systems. So many books are out there. And he is also a well-known author of computer networks. And Minix was the code that is attached in one of his books also, means a kind of documentation you can see. Part of Minix is available there. When we used to study in 2007 around, and then it used to come with the book only, the Minix code. So Minix code is available and it was developed with the intention in mind to have the academic hands-on and to have a kind of understanding of basic mini operating system. So it was developed by Android Andrew Tenenbaum, but it was not a kind of full-fledged OS, so didn't get so popular. But it became the base or the inspiration for many operating systems in the later era. So some of the initial releases with respect to Linux operating system, we do consider that version 0.1 and then we have the 1.0 and then 2.0 and then 3.0. So there were the different functionalities attached with all these versions. As you can see that with version 0.01, it was not obviously a mature product because when we say that it is the first release, then it is obvious that it comes to our mind that as it is the first release, it is not going to have all sort of functionalities. And when we compare that particular OS with all the OS those are available right now, then obviously how can we compare? So in terms of today's operating system, it's means not even a child. So it was very basic. But Minix like kernel for i386 plus based 80 machines. And in September 1991, the efficient use of 386 chip was there in the form of 0.01 version. And use of system calls are there in this particular version, then the message passing. And finally, the minimal task switching. Minimal task switching, that the minimum headache was there for a specific OS. Because as we discussed so many times in the previous lectures, whenever we switch a task, then we need to do the contextual switch and all those things. And there were some visible interrupts. Those were easily recognizable. Then the concept of multi-programming came into picture with version 1.0 and then reduced memory management and improvements in version 2.0, and finally the better handling of virtualization system support came in version 3.2. So in addition to all these initial releases, some of the current today's standard and very well-known, the popular releases of Linux-based OS are the Debian, SUSE, Red Hat, Fedora, CentOS, Ubuntu, and there are many others like Mint. We do have specifically for security purpose the Kali Linux and all. Okay, so in this way, so many different distributions of Linux you can see in the market, and when we say like I was discussing that usually we do compare money with money, but normally it is not like that. what I think that we should compare the impact with impact. What specific technology or contribution of a person or company made an impact on the livelihood of people and the life culture and the technological advancement in the society. So when we see Linux, then it is immense, obviously, because in terms of Windows and in terms of Apple, means everything is just for monetization purpose. They made money, but obviously it means making money is not a bad thing. But in terms of contribution cannot be money based, because when you do deliver money to people, means you are doing the philanthropic work, you are distributing money. You distribute money to people. You give 100 rupees or 10,000 or 1 lakh rupee to a beggar, but his life condition will not change. After all the spendings, he will again become a beggar only. But if you do provide some sort of education, then you make a kind of livelihood change for him. You make some sort of arrangement of job for him. Then it's a kind of lifelong change for him. And the sense of recognition will come into him. The self-confidence and all those things will come inside the person. So that is the change. That change cannot come just with money. So that's why when we see the environmental as well as the technological changes in the society, then I personally do consider that Linux is the biggest change. So coming with the specific 4 category wise discussion of Linux, because specifically we divided our operating system project in 4 specific categories. One of which process management, memory management, file management, and device management. Then with process management, starting with the concept of process ID is there in Linux operating systems, and there is a dedicated process environment inside which we do create processes, and then we do have the concept of execution also. So fork and exec, and those are the system function calls. Those we will discuss in the coming lectures in detail, how all these commands work and specifically what is the impact of all these commands in the generation and the termination of underlying processes. Then there is a concept of process context switch. Then we do have a particular context with respect to each process, as we do know, and we switch from one context to another whenever it is required. So Linux adapts all these concepts, because every concept means when we are discussing these things, and then one thing comes into mind, then we discussed all these concepts in advance already. Then what is so special here? Here the special is because the first thing that it is overview. So I'm not going in much details, but I'm going to tell you specifically which features are available in a particular operating system. So specifically our focus is Linux. So we are specifically discussing with respect to process management, what sort of things are present inside Linux, because it is not like that you have read hundreds of concepts and all the concepts are going to be the part of a particular operating system. And why not? That means question comes into mind that if we do have hundreds of concepts, why not all the concepts are part of a particular operating system? Because again, the OS will become so heavy. Because if you go for specific all kind of implementation unnecessarily, those are out of focus, then your OS will become clumsy. So many things means even the organization will become so difficult, because the underlying operating system coding is not so easy. And that's why every component needs a modular structure. If you incorporate so many features with all kind of attributions and other things, and then making a connection from means there are 2 terms. Those are usually occur in software engineering. If you remember, means I don't know you guys past history, means what you have read or not. There is a term cohesion and there is a term coupling. In terms of software engineering, these 2 terms are very popular. Coupling is a kind of, it's the interconnection of modules. Okay. So when we say a component, it means a software, because again, like we discussed in terms of segmentation, that memory is a big chunk of space for user point of view. So for a user, we normally see that memory is a big chunk and all the programs are a kind of randomly distributed parts inside memory. Similar way here, when we say that there is a software, then software is what? Software is a big program. Okay. And inside that big program, there are small components. Those usually called the subroutines, functions, modules, or whatsoever. Means in different contexts, there are different names. Okay. So here we call them modules. If, for instance, we consider. Okay. So there are multiple modules and all these modules have interdependencies. Okay. So these interdependencies will define the behavior or the functional efficiency of the overall software. So these are different modules have the interconnections. This interconnection is coupling. So if the coupling is strong, means that there is a dedicated connection between two processes or modules, then connection or means the communication is going to be really efficient. But if there is a temporary communication, you are again need to access the shared memory, and that shared memory communication is failing over the period of time again and again, then there might be a scenario that you usually fed up. Means obviously it is a system, it is a software, so it will not fed up, but its performance will go on decline because your response time will increase, and similarly the processor need to keep on track all the other activities, because if one process is taking too much time, processor will keep it waiting state only and will switch to another process. So again processor need to come back and then give execution time, so it will take time. So in this manner, we say coupling should be strong enough between all the modules and components. Similarly, there is another component that is cohesion. Cohesion specifies what is the inner strength. So coupling points to outer strength and cohesion points to inner strength. So cohesion means if a module is means a superset of multiple inside constituents, small parts, then the inner force that is binding all these modules together, that is cohesion. Okay, so you consider it like means if there is a big kind of you say there is a module, okay, and there are multiple hundreds of. Why I'm saying hundreds of? Because usually we see that if there are only 2-3 modules, why we are keeping those inside? Why not to be kind of just a sort of some distant connections or something like that, just listed those. But there are, if there are some dedicated sets of something, then those are the dedicated modules, module 1, module 2, module 3. Then inside module 1 there are hundreds of sub modules, small details. Then all those things are connected or are means those are forming a particular set in the form of module 1 because of their underlying force, that is the cohesion. So this cohesion is defining the inner strength of this module 1, and the coupling is defining the strength between these two modules, module 1 or module 2 or module 3. So the intercommunication is defined by coupling, and the inner strength of means the interconnection of the subcomponents of a module is defined by cohesion. So in this way, when we say that process management, there are multiple processes and you need to do the context switch from one process to another. Then again, you need to have set of all the process components. So whatever is there, the registers or the kind of memory stack heap and all those things. Okay, that is going to be part of PCB and going to be stored in a specific part of memory. Similar way, other process and all other things. Again, you need to do the context switch and all these things. So when we say there is a OS development is in the process and you want to incorporate all the functionalities, so there will be so many components that coupling will not be strong. If coupling is not a strong, performance it might not be good. And similarly, cohesion is also a question mark, because if you are trying to bind so many components inside a single component, then it is not always the guarantee that those are supposed to be really in good connection with each other. Okay. Second is the memory management. So in terms of memory management, we do have the physical and virtual memory support in Linux, and physical memory management is done with the help of paging, as we saw, and we saw in the previous discussion. And in terms of virtual memory management, we do have the virtual memory support, the concept that specifies means gives an assumption to the user that yes, we do have so much memory, don't worry about the memory, just come into and play. Okay, so virtual memory support is also available in Linux. Then we have the file management system. File management, the virtual file system is available there. Specifically, everything is saved in a virtual space in the form of file. Means everything is a file, and normally we call file also an object, because when we say inside Linux we do programming, then we usually imagine things in the form of object. We means you guys must be having the understanding of object-oriented programming. So whatever we are seeing in this world, everything is an object. Okay, so normally the set of objects we do define as a class, like we are the humans. So I'm a human, you are a human, and all the guys who are living around us, those are humans. Okay, so this is one category human, and we are single object. Means I am one object, you are one object, another person is another object. Similar way, we do have some sort of interconnections and all those things. So those are defined in terms of files also. So file is also stored in the form of object. Then particular file system that is specifically developed for a Linux system, that is defined in the form of extension. Okay, so normally we do read it as extension, but it is not extension, it is extended file system 2, that is in short written ext2fs, means extended to file system, but it is extended file system 2. In short, we write it like this. Okay. Then we do have a multiple sort of allocation policies, means how to allot the memory area to file systems, and what sort of permissions that you are supposed to apply on particular files. Then we finally have the device management. In terms of device management, we do have the block devices, character device, and the network device support inside Linux. And block devices are usually the memory devices, all sort of hard disk, floppy disk, CD drives. Those are the block devices because they do support the block transfer. Okay, block is the kind of basic unit that you define in terms of 4 bytes, 8 bytes, whatsoever be the size of block. Okay. Then character is an individual character. Usually, again, the character size might be the 1 byte or 2 byte. Then character by character, whatever devices are supporting that kind of functionality, like keyboard or mouse. And we do have the network devices for interconnection purposes. Okay. So in this way, we have seen all these things starting from Android, then Windows to iOS, then OS X, and finally Linux. Okay. So I'm going to show you guys finally. Okay. Till now, any question? If you guys have any question in your mind? Okay, so here I'm going to show you guys one more thing. Okay, so you guys can see this stat counter. Hello.
Yeah.
Yeah. So this stat counter is giving the current market share. Okay, means right now what is the market share of different OS, and as you can see here. Okay, I have considered means I have my current opinion based on these facts only. So these are the different statistics that you can see, means the current market statistics you can also see in your system. So Android, you can see that more than 41% market share is with Android OS. And I think means all these statistics are generated with respect to all IP devices. So there might be all sort of IP devices. Then there is more than 30% market share of Windows, then iOS getting with 16.53%, OS X 6.38, and there is an unknown sort of means there are some sort of personal developments, means you might be having some sort of open source implementation with your own improvements in the base code. So you have not allowed that particular implementation for public use. So that's why those are unknown. And there is a dedicated 1% Linux market share. So it looks very small, but obviously its impact is very high in terms of research, in terms of computing development, all these things that I was discussing. That in terms of Windows and iOS, means Android and Linux, they have changed this whole computing market. Okay. Then specifically Windows version market share, if you want to see, then we can see here that Windows 10 is the leading with a 78.43% of market share, and then Windows 7, Windows 8.18, Windows XP. XP is quite old, okay, but still it is having this much share. It's quite commendable, because in today's era, if you are having even 0.5% share, then it is a big thing, because it is very old, but some of the functions are so good. Means it kind of, if I don't know whether you people might be having some experience of XP or not, but if you want to see some of the videos of XP, then I will recommend that go online and have a look of XP, because many people do get it means very charmful. They consider that XP look was really good, so they do admire that XP could have been better exposed in new versions also. But later the Windows 7, 8, and then finally the 10 series became so popular. Then Windows Vista was also considered very good by some of the programmers, but some of the general users who don't have the good system configurations, those were not capable enough to hold the support of Windows Vista. Okay. Then we do have a different macOS market share. So here you can see that Catalina is leading with a massive 77.21% support, and then there is a Mojave, and then High Sarah and Sarah, then El Captain and 10.10 that we discussed there. So those we discussed with the initial releases. Okay, those initial releases are still in use. It is not like that, because those are, as I was discussing the point that Mac OS is not supported by so many people even today, despite its numerous features and applications, because the main thing is monetary support. The economical condition of people is not good. If we compute the billion population in our country only, then how many people can afford Mac sort of system? So that's why if your underlying hardware is not good, even people are not in a condition to afford a good hardware. So if they are not able to afford a good hardware, how can they afford good softwares? Okay, so here you can see some of the old OS like OS X 10.10 and the Windows XP Vista, those are still in because people are having old systems. Okay, then finally iOS versions you are must be familiar already. Okay, so 14.6 is leading with 16.62% support, and there are some others. Okay, up to 14.7. Then finally comes the Android. So here you can see 31.17% support from 10, then 11, then Pi, Ori, Marshmallow, and all. Okay. So with respect to India, okay, it is taking too much time. Okay, leave it. So I want to show in India, this is the scenario. Okay, in terms of Android, and what is the worldwide scenario? So it is the worldwide scenario. Okay, so in this way, you can see and you can have a support of different OSs, and you can understand what is the current market condition. Okay, so finally, this is the last class of overview, and it is going to be kind of means here I'm stopping. And if you guys have any sort of question, okay, then you can ask. Then please let me know any sort of means in this last class of overview, because the next class onwards we are going to get forward in a formal way. Okay, then any kind of suggestion, any sort of recommendation from your side, and don't pause yourself in terms of discussion, and don't limit it just to yourself. If you want to have any sort of criticism also, then you are really welcome. Means because it's a mutual development. I am offering something to you. So in return, if you give me some sort of criticism or some sort of remarks, then it's really commendable. Okay. So do provide me all sort of your comments, whether those are positive, negative, whatsoever. Then I will try to improve myself. And in terms of speed, content delivery, or whatsoever, because these were the 4 lectures at 2 weeks time, and I need to cover all the concepts in detail, because when we say that we are giving the brief introduction, then introduction I think should be very much detailed, because when you can give everything in short, you can offer the overview in detail. I mean, normally kind of contradictory thing, means we are saying the overview but we are going in detail, but still you need to do all sort of coverage of a subject, so that the underlying means the internet audience need to get a flavor, means exactly what we are going to be in touch with, and exactly what and why we are reading this particular subject, what is the importance, and all these things will become clear. So any sort of comment, is most welcome. If you want to give, then please.
Professor, I think sometimes your mic has like a lot of static or some like noise while you speak. So that's the only thing. That's a little bit hard.
Yeah, Nikhil. Now it's fine.
Yeah, I think now it sounds better.
Okay. So I was saying that any sort of comment or any sort of improvement that I need to do from your side, please let me know.
Professor, just a question. What will be the first topic that we're looking at formally?
In terms of performance, what I'm looking at?
No, Professor. What the first topic we'll be looking at next week?
First topic in the next class?
Yes, Professor.
First, obviously, I'm going to start with the second. Okay, I will provide you the documentation also. I will try to upload it. I discussed yesterday with some of the seniors and colleagues. So shortly, means within 1-2 days, I'll upload all the things. But I'm going to start with process management because specifically those means there are specific 5 kind of units. First is the overview of operating system. So these 4 lectures, I think, have covered the basic overview of everything. Starting from operating system to the case study. So specifically, I'm going to start with the second unit, that is process management, then memory management, then your file management, and then finally device management. Okay, so next lecture will be on process management. Any other doubt?
Professor, I had one request.
Yeah, sure.
Yeah, so Professor, the content and all is very clear. Could you just make the class a bit more interactive, like
actually
with discussions and all?
Yeah. Yes, because that's why I was saying that all these 4 lectures were kind of little informal, and I was asking means any sort of input from your side, but as it is the fresh course for you guys also, so that's why lots of input were not coming from your side. But as we are going in a formal session from next class onwards, so every concept that I will discuss, I will take your input also. These 4 lectures were delivered with a intention that you also have a basic fundamental feeling that what exactly an operating system is. So now next means next class onwards, whenever I will discuss a concept, no concept will be like that that you don't have a idea. Means what is this thing? It's a very fresh term for me. It is never going to be. So whenever I will discuss something, I will ask for your means input, means what you have understood from the initial brief overview lectures about this particular thing, this particular concept. And if you have any sort of other extra information that you want to add on, then those are most welcome. So definitely it's going to be interactive.
Thank you, Professor. Thank you.
Yeah, you're welcome. Any other? Okay. So any particular comment means in terms of improvement means either content is means when I was delivering the content, so obviously these were the overview slides, so I kept the content very short. But I do believe in keeping content short because you also don't need to write so many things. And in the exams also, I do expect that you need to the point. Means unnecessary things should not be there. Yes, the best way is that the preciseness and conciseness. Okay, more content, but should be to the point. Maximum content. And many times people do means these things do come into picture that how to score more or how to be kind of why he has got more marks or something like that. So you need to put more details, but in a specific manner. Means those need to be very concise, but very precise. Okay, and towards my delivery of lecture, my pace and the content or sort of any other thing, because in these slides there were no figures, because if I used to put all the figures and all, then obviously the slides would have been more, and covering the whole syllabus in 4 lectures was not possible. So that's why I didn't put more kind of figures and all. But next lecture will be in formal fashion, so there will be some figures, some little bit discussion, and all the mutual exchange of words. Everything will be there. So in addition to these things, if you want to add something, then please let me know. And especially in terms of, because many times I do feel that I'm doing bit means fast or something, many times because I think sometimes technical errors do also come. Then we do not get in touch. The synchronization is lost. So whenever there is a something like that, please let me know. And means through chat, obviously you have done that yesterday or day before yesterday it happened. So any sort of improvement in terms of communication, in terms of delivery, then you can tell me, frankly. Okay.
Now that the 2 weeks are over, will you be uploading like the full course syllabus and grading and all that on the Canvas page?
Yeah.
Okay, sure.
So any other doubt? Okay, guys. So consider